Hi, in this video I'm going to talk about cryptographic hash functions. So we'll first understand what are cryptographic hash functions, properties of cryptographic hash functions. What are cryptographic hash functions? Cryptographic hash functions are mathematical functions that take an input or message and return a fixed size string of characters which is unique to the input. We'll understand this fixed size string of characters while doing our blockchain demo, so don't worry about it. The output of a cryptographic hash function is often referred to as the hash or the message digest. Two examples of cryptographic hash functions are MD5 and SHA-256, but SHA-256 is considered to be more secure than MD5, and it's widely used in various applications like blockchain. It's possible to hash data, images, books, and videos using SHA-256. Cryptographic hash functions can be applied to any type of data, regardless of its format and content. For example, you could hash a text file, an image file, a PDF document, or a video file using SHA-256. The hash function will take the data as input and produce a fixed size output, as I mentioned, that is unique to the input. Okay, so for example, you have a book, your text files, video, image, you put them into an algorithm called SHA-256, and this algorithm will give you an output hash. So properties of cryptographic hash functions. The first one is they are one-way. It's computationally infeasible to determine the original input from the hash value. For example, it's difficult to determine the original message or data from a hash value. So deterministic. The same input will always produce the same output. For example, if you hash the message hello world multiple times, you will always get the same hash value. If you are using it on a different environment, different editor, the same algorithm, it doesn't really matter. You will get the same hash value with the same input. So they should be fast and efficient to generate a hash value from an input. For example, it should take only a few milliseconds to generate a hash value for a message or data input. Collision resistance. It should be difficult to find two inputs that produce the same output. This ensures that each input is unique and distinguishable from others. Avalanche effect. A small change in the input should produce a significant change in the output. For example, changing one letter in hello world should produce a very different hash value. When you change something in your input, it's going to affect a function in the algorithm, and it's going to affect another one, and this will create an avalanche effect in the algorithm, and the output that you get will be completely different. So that's going to do it for this video. I will see you in the next one.